Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Mayfield. And in this video, we're going to be talking about some theoretical probability, and we're going to be talking about some experimental probability, and some similarities and differences between those. So on that front page, it says this. It says when all possible outcomes are equally likely, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. And we would say that the probability of an event is written as P of the event. So you use that capital P to show for probability, and then you have those parentheses, and then inside you write whatever event that is. And so when we're talking about that ratio that is there, we are talking about in our numerator, we would have the number of favorable outcomes. That's how many times that event happened. And then in the denominator, we have the total number of possible outcomes. So you want to make sure that you have that in your head and on your page. So in the first example, it says this. It says you randomly choose one of the tiles shown. What is the theoretical probability of choosing a tile worth more than 1 point? So how would we write this? Well, we would say it similar to this. We'd say, all right, the probability of picking a tile more than 1 point is going to be equal to, and we would say, well, it's going to be 2 over 6. And how do we get that 2 over 6? Well, we know that in the numerator, the 2 comes from that there are 2 tiles worth more than 1 point. We would say that there's the K and the Z. Again, those are worth more than 1 point. And then where do we get the 6 from? Well, we got the 6 because there are a total of there's a total of 6 tiles. So that's how we get the 2 over 6. Always want to make sure that you can reduce that fraction to simplest form. And so we're going to divide by 2 over 2. Again, that's that greatest common factor. And so then we get a simplified fraction of 1/3. We also want to make sure that we have our fraction decimal percent, and so I usually like to write it like this. I would say that my fraction is equal to my decimal, which is equal to my percent. So I'd say 1/3 is equal to 0.33 repeating, which is also the same as 33% repeating. So you want to make sure you can switch between those forms. In the second example, it says this. It says, what is the theoretical probability of pulling a tile worth 5 points? So we're looking for a tile worth exactly 5 points. And so we would write it like this. We would say, all right, we have the probability of picking a tile worth 5 points is equal to, so we got to have a fraction. And so we're going to have a fraction that looks like this. We're going to have a fraction that says 1 over 6. Where do we get those values from? Well, in the numerator, we'd say there's a tile worth 5 points. There's only one tile worth 5 points, and we would say there's 6 total tiles. Since we don't need to simplify that fraction, it's already in simplest form, we can just let it as is. So our fraction form is going to be 1/6. And then we could say for our fraction decimal percent, we want to make sure that we can change it between those forms. So we have 1/6 is equal to, and we have 0.16 repeating. Again, that little line above the 6 means just the 6 is repeating. And then we have, as our percent form, is 16% with a 6 repeating. So now after that, it has on the back, we're going to talk about experimental probability. So experimental probability is based on repeated trials or occurrences. So this is when you actually record what happens. So we'd say in the numerator we have, it's the number of times the event occurs over the total number of trials. So it's pretty similar to how we have it set up in theoretical probability, but we are recording those occurrences. So for the third example, it says the bar graph shows the results of spinning the spinner 40 times. What is the experimental probability, of spinning green? So we're looking at, they would say that we would spin that spinner 40 times, and then we would record these outcomes. So now we're saying, okay, we're looking for the probability of picking a green, meaning how many times did that spinner land on green? Well, we'd have to read that wonderful bar graph and would say, okay, well, we're looking at green and we're looking at, it's going to be 8 times. So we would have 8, and we say we got 8 from the spinner being spun 8 times. And where did we get 40 from? Well, you could add those all up, or you could just see in the problem, it says it right there. It says there were a total of 40 spins. And if you notice, hey, I can simplify that fraction. I want to divide both the numerator and the denominator by 8. And so I divide by 8 over 8, and I get a simplified fraction of 1/5. You want to make sure that you can also show that fraction decimal percent in each of those equivalent forms. And so I'm going to have my fraction decimal percent as this. I'm going to say 1/5 is equal to 0.2, which is the same thing as 20%. So I'd say something like this. I would say the experimental probability of the spinner spinning green would be 20%. For the fourth example, it says, what is the experimental probability of spinning red? Well, how many times do we spin red? So we have to be able to read, how this bar graph shows. So I'd first say that the probability of the event is P in parentheses red is equal to the fraction, and I'm going to say it's going to be 7 over 40. And I would say this. I would say, hey, the spinner was spun on red 7 times. And then I would say that there's a total of 40 spins. I know that I cannot simplify that fraction any further, since the greatest common factor is 1 between 7 and 40. Then I would say for my fraction decimal percent form, I would switch between those different equivalent forms. I'd say my fraction 7 over 40 is the same as 0.175 for the decimal. And then for the percent, I would say it's 17.5%. So any of these forms would be true. So it's say that the experimental probability of spinning red based on this bar graph is 17.5%. So now for this last example, we want to take, and we're looking at a new bar graph, but we want to say, okay, hey, what happens when we spin that spinner 200 times? So it says to find and compare the experimental and the theoretical probability of spinning green. So let's find out how this works. So we just did a couple experimental, and so we're going to try them out. So again, you write it like this. I'd say that the probability of spinning green based on this bar graph is going to be 47 over 200. Again, we got that because we said, hey, it landed on green 47 times out of the 200 times we spun the spinner. Again, you can write that as a fraction decimal percent. Again, I like to write each of those forms, and so it'd say the fraction is going to be 47 over 200. The decimal is going to be 0.235, and that means that my percent is going to be 23.5%. However, when we take the theoretical probability, what would we say? Well, we look at this wonderful spinner that is right in front of us, and we'd say, okay, what is the probability of landing on green? Well, we would say the probability of it landing on green is going to be 1/4. And I'd probably say, Mr. Shank, where'd you get that 1 or that 4 at? I don't see any numbers like that. Well, I'd say how many sides or how many spaces have green on it? Well, we would say that there is only 1 space with a green on it, and there's 4 total spaces. So I'd say the probability of spinning green is 1/4. And so then again, lastly, I would say my fraction decimal percent would be 1/4, which is equal to 0.25, which is the same as 25%. And so when you're comparing these two values, what are you thinking? Well, we just did one where it had the theoretical probability of spinning, we had the experimental probability of spinning green. We said that was about 20%, but now when we increased it, we increased the number of trials, we went up to 200. So what do you guys think? What do you think? What would a conclusion be? Well, I could say something like this. We could say, as the number of trials increased, the experimental probability becomes closer to the theoretical probability of 25%. And so you want to make sure that you're saying, well, where did I get that from? I want to say that it is getting closer to that amount. Also, you want to make sure you can spell probability correctly. Probability. There we go. Spelling's not my strong suit, so luckily for you guys, I stick to my math and numbers. And so all I'm doing is saying, as those number of trials gets higher and higher, we know that it gets closer to the theoretical probability, meaning that this is always going to be your main idea or your main outcome. As always, make sure that you are following along with that. You can hit that replay button, and as always, super slam that subscribe button.